All right, so for some of these problems, the first thing that you want to do is find out and ask yourself, is the square root problem that you're given a perfect square? Well, we know that 6 times 6 equals 36, which means that 6 squared equals 36. That means inversely that the square root of 36 is equal to 6. Okay, so we know that the square root of 36, since it's a perfect square, is equal to 6. Um, some of them might be perfect squares like this one. Some of them also might be numbers that are not perfect squares. So there's no two numbers that when you multiply it by itself give you 27. So what do you do in that case? So what you want to create is a factor tree of the number underneath the radical. So we have the number 27, and we just think of any two factors of 27. So we have 3 and 9. 3 is prime, so we circle it. 9 is not prime, so we break it down. 9 is a product of 3 and 3 is prime, so we circle them. So we can rewrite this problem as 3 times 3 times 3, because 3 times 3 times 3 equals 27, right? And we want to break it down into our prime factor tree. So that is important, that this is our prime factor tree, right? So we have to get this down into all of our prime numbers. And I'll put a list of the prime numbers at the end. But your first couple of prime numbers, you have like 2 is a prime number, 3 is a prime number, 5 is a prime number, 7 is a prime number, 9 is not, 10 is not, 11 is a prime number, 13 is a prime number. These are just numbers that that only have factors of 1 in themselves. Yep. All right. So we broke this down into the square root of 3 times 3 times 3. We can break that down even further. We know that 3 times 3 we can rewrite as 3 squared. So this would be the same thing as 3 squared times 3, right? Because 3 times 3 would become 3 squared. Then we could break that down a little bit more. And I'm just going through all of the steps just to show you the long way, and then I'll show you a shortcut at the end. The square root of 3 squared times the square root of 3. And the square of 3 and the square root of 3 are inverse operations, so they kind of cancel out like multiplication and division do, because this would technically be like the square root of 9, right? Which we know is already 3. So we just get this. This is our final answer. And we write this, or we say this as 3 root 3. So our final answer would be 3 root 3, or 3 times the square root of 3. Let's try another one. So a slightly bigger number. We're going to start with creating our prime factor tree. You can do 8 and 5. You can do 4 and 10. It doesn't matter what factors you break it down into, as long as you get your prime factors at the end. So let's do 4 and 10. Neither 4 or 10 is prime because you can break them down even more. 4 is 2 and 2, and 10 is 2 and 5. Every time we get a prime number, we want to circle it, right? So what we're saying is that 40 is the same thing as saying 2 times 2 times 2 times 5, right? So we have two 2's here, which we can rewrite as 2 squared times 2 times 5. So we can rewrite this again as a square root of 2 squared times the square root of 2 times 5. Oops, times 5. So again, these two cancel out, or you can think of this as the square root of 4, because 2 squared is 4, which will just give us 2, times the square root of 10. So again, we just write this like this, and we say that the answer is 2 root 10. Okay, so that would be your final answer in Delta Math, 2 root 10. So basically, if you've noticed a pattern, you're looking for any pairs when you get to your prime factor tree. Any pairs go on the outside of your of your radical house as one number, and then the rest goes on the inside of your radical house as one number using multiplication. So these two 2's we put on the outside, right? And the other 2 and 5 went on the inside as a 10. So I will try this last one since it's a bigger number, just using that trick and see if we can work from there. So again, we're going to start with our prime factor tree, 160. Well, I know that's 16 times 10. I know 16 is 4 times 4. I know 10 is 2 times 5. 2 and 5 are prime. 4 is not. 4 is 2 and 2. So the way that this would work is these two 2's would go on the outside of my house as one number. These two 2's would go on the outside of my house as one number. And these remaining numbers would go on the inside of the house using multiplication. So we would get 2 times 2 square root 10. So our final answer would be 4 root 10. Okay? Because again, these 2's would become the square root of 2 squared, which is just 2. These 2's would become the square root of 2 squared, which is just 2. And those would both be on the outside as a whole number because they would make a perfect, perfect square. And then all the numbers that are left over go on the inside of the house using multiplication. So, yep,